Hello, and welcome to the development phase. All right, now we got through the planning phase, we got through the analysis phase, we got through the design phase, and now we're ready to develop the system. Yay. So it took us a while to get here, but hopefully now we're at this point, we know exactly what it is we're going to be developing, how we're going to be developing, and all we really need to do now is just put, pen to paper and start coding it, testing it, and so on. So the development phase, what we want to do is talk about what it is, and then we'll talk about the steps involved. You're probably going to be surprised about all the possible steps that actually take place in the development phase. As I said before, the development phase takes the design that was developed based upon the requirements and the functional requirements that were derived based upon the analysis of the process analysis. Usually what happens is the process analysis actually does, usually brings out the logic and the business rules that need to be placed into the code itself. That's where a lot of our logic comes from. Okay, so usually what happens is the analyst provides the programmers with the functional requirements, and then the programmers take those functional requirements and design their their solution for this based upon the type of methodologies they're using to write their code. We'll talk about that here in a second. That pretty much takes care of it. So what we do is we take that information, we develop, we test, we document, and we implement the supporting solution. Sounds pretty easy. Let's go into the steps and kind of talk about what actually happens. The development steps at this phase includes or all of the following, basically design, code, test, document, training, data conversion, and installation. All of these can take some time, and it usually requires a coordinated effort to really kind of put this thing together to make sure we stay on track and on budget as we go through it. Each one's equally important. You must design what it is you're going to be writing. You must know how you're going to implement it, especially based upon the methodologies like structured programming or object-oriented programming and so on. If you're into object-oriented programming, you've got to implement object-oriented design to truly understand how you're going to build your classes and so on. And we'll talk about that. We're going to code it. We're going to test it. It's really important to test everything and anything that you're going to put out there. There's different phases of testing, and we'll talk about that. You need to document your code. We'll talk about that. You need to train your people who are going to be using the system. You don't want to develop something and make sure that, and you want to, if you're going to develop something that's cool, I should say, you want to make sure that they, truly understand how to use the system to peak efficiency, not just here and there and everywhere. You want to make sure they understand truly how to use it. Data conversion can be a real bear, and we'll talk about that a little bit, and then finally the installation. You would think installation of a system would be easy. Well, it's not so easy either, based upon what you're doing. If it's brand new, that's one thing. If it's not brand new, that's totally another story, and we'll talk about that as we walk through. All right. Design. The goal is to design a solution based upon the functional requirements. We talked about that. The solution is one that should be well thought out for the purpose of developing the initial solution correctly the first time, developing a solution based on future needs and enhancements and maintenance. So what we're saying here is that, now that you got your functional requirements, once you understand the prototypes and everything else that comes in previous phases, now it's your time to really kind of lay out how you're going to apply this code and really think through the logic of what's going to happen. All right. Design should include, and it's really based upon the architecture. Regardless of what you're doing and what you're going to learn as you become better application developers, is that you want to write programs that will allow you to minimize redundancy and maximize reuse. Okay, so if you're doing a structured design, okay, based upon the languages you may be using, a non-object oriented environment, you still want to take care of that. You still want to make sure you're minimizing the redundancy of the code. So you want to build modules and you want to design this thing out that you can actually take advantage of the reuse of modules. Including in that, you also want to make sure you're building a system that is well maintainable, very easy to use. Okay, so to do so, you want to build module for structure design. You want to build modules based upon a hierarchy structure. You want to build the logic that will be in every module. Each module should have one purpose. You don't want to be building modules that's doing 2 or 3 or 4 things. You want to be building a module that has one purpose. And if you do that, the opportunity for reuse becomes greater. Each module should be developed, as I said, for opportunities for reuse, the last one there. Okay? So there's a lot to design. Don't minimize design. Matter of fact, it's probably the most important step in developing that there is. Okay? You need to have a plan of attack and going after it. Okay? And you need to design everything out based upon prior to starting the code. If you don't, you're going to come back and be doing the same things. You may be fixing things that you didn't have to fix if you just would have thought through it to begin with. All right? If it's object-oriented, and we're in an object-oriented environment, okay, and we're using object-oriented type programming languages such as Java, C++, um, .NET, and so on, more than likely your place of work or wherever you're working at probably has some type of standards on how to build their classes. Once again, to maximize reuse. Okay, so the places I've been that dealt with object-oriented, we had a lot of analysts kind of deal with how the classes should be derived. And they're usually working with the programmers to do that. So then the programmers, when they get those requirements, they need to be able to take that and build the classes accordingly. So hopefully by this time, or maybe not by this time, but something you're going to learn later is how to build these classes. Classes are based on the definition and attributes of an entity. Okay? Properties are defined based upon the characteristics of the entity, and methods are defined as behaviors which are the logic within the class. Okay? If once again you don't understand what I'm saying here, I don't think I want you to worry about it too much. But what I want you to do is when you're going, you will get into this, okay, if you haven't yet, into object-oriented programming languages, understanding what these things are. However, you must understand, though, that the classes you're going to be developing these languages usually comes from the design. And hopefully, when you get in those courses, it's well explained on how that all works. Okay? So that's design. So now when you have your design, you know what you're going to be writing, now you're ready to finally code. Yay! Everyone wants to dive into the code, and I hold them back a little bit. I'm a big believer in holding everybody back and designing everything thoroughly so the coding phase does not take that long. All right? But as you may well know, coding it uses one of several different languages based on the need of the application and the history of the company. I get a lot of questions on why are there so many programming languages? Well, that's a great question. I'm not sure I have a great answer. I mean, everybody does things a little bit differently. Everybody thinks there's a better way of doing something. It's based upon the environment. It's based upon the servers that are being used. You know, at one point in time, everything was, IBM. Well, people got tired of IBM and they went to, Sun Microsystems, which actually got into C and C++. Microsoft came around, obviously. A lot of people went to Microsoft. People started hating Microsoft and started doing open source. And so you start seeing more PHP and MySQL and those types of things. Java came in. Java became a really popular language because it's cross-platform and it can be used on many different platforms as it goes through. So there's a lot of different reasons for the programming languages that are chosen in a particular company. And they may be using a few of them based upon what they're doing and how they're doing it. Everything from older languages such as COBOL and RPG, all the way to newer languages such as PHP, ASP.NET MVC, Java, I spoke of, C++, and good old C is making a big comeback now with the Internet of Things. And so, every year things change, and what becomes old all of a sudden becomes new again. There's an old adage in IT that, just wait a little while, and what you did 20 years ago will come back and be popular once again. I have seen that throughout my career. It's amazing how things cycle through. But nonetheless, that's the programming languages, okay? I'm also a major believer that once you start understanding certain programming languages, especially object-oriented programming languages and different structure programming languages, you know how to program. I don't think you need to be handheld to learn every programming language, okay? I think once you understand how to program, the fact that you got to declare variables, that you have to have data types, there's logic, there's conditional logic, iterative logic, sequential logic, there's arrays, there's databases, there's I/O to databases. That's the same in every programming language, okay? So as you learn more and more of them, you should be able to pick up more and more of them. Testing. If you put what's important in the first three steps we just talked about, design, code, testing. I put design at 40%, testing at 40%, and code at 20%. I find coding to be the easiest part of everything. But now that you coded something, you need to make sure it absolutely works. You don't want your user to be finding any kind of mistakes out there. It could be logic mistakes, like those could be devastating. The program could abnormally end and all of a sudden just blip off. You've probably seen that before in some Microsoft applications. We as developers don't want that. And to ensure that doesn't happen, we need to thoroughly test our applications. I am a major believer, and I've actually been shown and trained on to ensure that every line of our code is tested and it works well. It does take a little while to do, but if the thinking, once again, this is something you got to think through prior to diving into your code. All right. To do this, the developer must create a test plan to test all conditional paths and all possible unique situations. If we sit back and we build our application and we do it in modules or classes, all we got to do is test each one of those particular classes. Okay? And then what we got to do is we got to, integrate those together. So our test plan must, make sure we test all the paths. When I say paths, conditional paths in every class, in every module, and so on. If we do all that, it's actually pretty simple to make sure we got our expected results coming out of that. So what testing includes is this: testing each individual program unit that a developer writes. Once again, this could be one program, this could be a module, this could be a class, and so on. Once the programmer tests that and it actually works exactly the way you're supposed to do it, again, you're going to test every path and every unique situation within that class or module. Then what you're going to do is you're going to test the integration of all the classes and all the modules that maybe you wrote or somebody else wrote to make sure they all work together based upon what the application is supposed to do. That's called integration testing. Once everything is finished and you got your whole system finished, so you're going to test the individual, you're going to test like one class, call another class, or however you want to do that. That's the integration piece. Once everything is done, you got to devise a plan to test the entire system and make sure it's working exactly the way it's supposed to work. Finally, what you're going to do is probably once you feel good about your units, about your integration, about your system testing, you need to then allow your user to attack it and literally try to break it. I always say that to them. I usually give them a plan of attack. I want them to go in and beat on it. I want them to find logic errors if possible. I want them to find unique situations that maybe doesn't meet exactly what they're actually looking for at this point in time. Okay, I want to make sure if there is any hidden things out there in this system that could potentially abnormally end the program, I want the users to find them now, not when it goes into production. Let's talk about that for a second. There's usually two stages of development. One is the development of it. So it's not live. We're not using live data. And I usually call that development. That's usually the development stage. Once everything is working, once everything is tested, and we go live with it, I call that production. Okay? That's my term. That's a term I grew up with, or I guess my career has been evolved around with. But based upon where you go work at, these terms might be different. There's usually a development stage and a production stage. All right. Now that we have everything working, we got to document. Usually programmers hate to document things. They love writing code, but they don't want to document what they did. But I can tell you, it's one of the most important things you can do. It cannot be assumed or will ever be the case that the developer of a particular program will be the one that maintains and enhances that program. I have written program for AT&T many moons ago, and I can tell you that some of those programs still exist today. Okay, when I say many moons ago, we're talking about late 80s. These programs still exist today, and somebody had to enhance them. I don't work there anymore, and that's going to be the case for the majority of things that you write throughout your career. It needs to be considered for the next generation who's going to enhance it. So not only should your code look good and following the standards and the naming conventions and so on, it also should be documented in English and with some technical, with some technical specifications about exactly what you're doing. That's what documentation is all about. Again, use the English paragraphs. What's going on? Where do you put this documentation? Well, you can put it in your code. There could be a manual that documents everything you're doing. It could, and or so on. It could be a technical specifications if you want to get more technical, like this is the data that's coming in, this is the data going out, blah, blah, blah. You need to document it. Based upon the maturity of your shop, they will probably ensure that this happens, okay? However, I've seen places that aren't very mature. What I mean by very mature is maybe a smaller company, doesn't have a big IT staff, and they don't have any clue what it means to document a program or the future of that program. Now you do. So no matter where you're working at, make sure you document what you're doing for the next people coming that's going to be using that system or maintaining that system. Okay, training. Like documented, the developers also need to develop training materials to train the users on how to use the application appropriately and thoroughly. Once again, you just created this wonderful application for the users. They need to make sure they know how, you need to make sure they know how to use that completely. In my experience, sometimes I'm doing this, and sometimes I'm hiring people who are specialists in education and human interaction and so on to help develop these types of materials, okay, with me. Once again, it's based upon the maturity and the size of the shop. When I was with AT&T, they had educators, and they would work with the technical team to actually develop the training materials to make sure it got across correctly, utilizing learning theories and so on within them. If you're not there, very simply, it's going to be up to you to make sure you're empathetic enough to develop these training materials with the user in mind to show them exactly how to use the system. I can't stress that enough. You need to be empathetic enough with the user in mind, not you, because you built it. It's easy for you to use. You need to back off a little bit and go through and develop the training materials with them in mind who have not developed it, and in some cases may never have seen this system before. And in some cases, this is requiring a big change to them. So you need to make sure the training materials are very thorough and, uh, and so the user can use it the way you intended them to use it with all the using all the cool things that you put into the code to make it actually work really, really well. Does that make sense? You know what I'm talking about. Like, it's just look at an application like Excel. All of us can use Excel a little bit, but boy, if we were trained on it to use it to a full extent, what could we possibly do with it? It's the same thing here. We have now been paid to develop an application. We want to make sure our users are using it thoroughly, and you got to train them to do it. Data conversion. If you're replacing an older system application with an existing database or other forms of data access, then you will need to determine how the old data is going to get into the new database. At its most difficult, programmers may need to write a very sophisticated data conversion application to get the old data to work correctly with the new relational normalized database that supports the new application. And this isn't easy. I have seen people make a career out of doing nothing but being data conversion specialists. So let's think about it. We might be writing a brand new system that's replacing maybe 2 or 3 systems. We might be taking old systems that were using older databases, maybe not as databases that are as normalized or that they should be, and putting a brand new spin on it, and a more integrated environment, so to speak. If that's the case, we've got to get all that old data over into the new databases. Okay, if we just don't start from where a brand new system, we got to go get all the old stuff so the old stuff works with the new stuff. Does that make sense? In that case, what we need to do is we need to make sure that to do that, it can require a lot of work. I can't really even explain to you the amount of work it takes to get old data into the new database. Excuse me. Once again, the new data might be a very normalized relational database. And if for those of you who know what that means, hopefully you can understand what I'm trying to say. If you haven't taken that class yet or you're taking it right now, I think you will. If the older data is in some type of Excel spreadsheets, flat file systems, older type of database technology, you got to get all that over and get it into a normalized way. So usually what it is, we have developers writing software that will actually take the old data and convert it to the new. This could take a while, and once again, could be very difficult. Okay, you would think that installation would be simple. In some cases it is. However, if you're replacing a current system application, many things must be considered, including the changeover method that are chosen to be used. What do I mean by this? A brand new system, not replacing anything, would be a simple install and final testing and go live. So you may have you built something brand new for somebody, and there is no old data, there is nothing, and you're not replacing anything. Piece of cake. Bang, 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 install it, start using it, everything is cool. However, in reality, usually what you're doing sometimes is replacing older systems. So just like I mentioned before with the data conversion, if you're replacing those older systems, a plan needs to be in place on how you're going to do so, okay? If you replace the old system, methods to consider are a direct cutover, meaning you end the old system and you start the new system the next day. That's high risk. If something happens with the new system or it doesn't install correctly or whatever, and this system is really important to the company to do its daily work, that could be a very high risk. If another way of going about it is parallel, meaning you run the old system with the new system at the same time for a while, for a period of time. It's kind of monotonous because you're actually entering data in both places. But what's happening here is that you're minimizing the risk and you're allowing things to flow through to make sure the old system is producing the same thing with the old system. I'm sorry, the new system is producing the same thing as the old system used to be. Does that make sense? So what we're doing is we're still running the old system, we implement the new system, meaning we install the new system, and we're running them both at the same time until we feel very comfortable with the new system, and then we finally let the old system go away, and everybody just starts using the new system. That's called parallel. What's a period of time? I don't know, weeks, months, all based upon the complexity of the system maybe, and how important it is to the company. Another one's a phased approach, where you just implement phases of the new system over time, okay? And we're gonna implement this first, this second, this third, this fourth, along with running the old system at the same time. Okay, so you're running the old system and the new system, and you're just putting pieces in the new system until you feel very comfortable with it, and once again, you cut off the old system. How do you know which one to use? Well, it shouldn't be exactly all your decision. It should be a team's decision on the best way of going about doing this, once again, based upon the sophistication of the software, the importance to the company of that software, meaning is it an accounting system, is it a transactional system, is it something they can live without for a couple days, might dictate that let's just do a direct cutover and see what happens. If they can't live without it for more than a minute or two, parallel and phase should be considered. Does that make sense? You'll learn all about that when you hit the industry, trust me. Okay. So there's a lot to implementation. I hope you got that in this short, quick video. Maybe you think it's long. Than just developing and go. Many things need to be considered. The methodologies on the design, the language to code it with, the test plans, the documentation, the training, the data conversions, and then how to install. All of these, usually what happens is that, once you get to the development phase, a project manager is involved, and usually what happens in a mature environment again, one that has a few programmers involved and analysts and so on, is everybody sits down and starts planning out how to do the development phase, what needs to actually happen. Tasks are assigned, people are assigned to those tasks, and then basically a project plan is put in place to basically, go through the entire development phase. That's usually how it works. Not every shop does that, and once again, if you go off and become a programmer by yourself and you're just doing your own work, you wouldn't do that. But I welcome you to think it through, though, before you actually start the development phase. Okay? So for our purposes, this is the SDLC. We went through the 4 phases we talked about in the very first video about the SDLC that we were going to discuss. These 4 phases. I hope it at least gives you a high-level explanation of what goes on in these phases, and hopefully you can respect the fact that by starting with the idea, making sure it's a feasible idea, getting into the requirements, getting the details, proposing a solution, designing that solution, and then finally developing that solution, that you can respect the fact that if you walk through those phases in one form or another, no matter based upon a small application to a large application, you can see that by doing so should help you ensure that you're doing it well and you're doing it right the first time, okay? And that your users are going to be happy with you when it's all said and done. All right? Anyway, the final phase that a lot of applications have, I'm sorry, a lot of models have for the SDLC is maintenance and enhancement, okay? We didn't talk about that in this particular course, but it's there. So maybe something you might want to go look into a little bit later on, okay? So that's it.